morning children, welcome to your science video lecture. So as you all know that in science we are doing our chapter number 6 from our NCERT book by the name Changes Around Us. Okay, and in our previous video we have talked about what are changes and how many types of changes there are. Right, in this video children we will be discussing about the two specific type of changes, that is reversible and irreversible changes and physical and chemical changes. Okay, we will be discussing these four changes in detail in this particular video. Okay, so before moving on to these changes, I would like to recall that what we have read in the previous video, so that you have a quick recap of what we did, and through that it will be easier for you all to understand the changes that we are going to start after that. Okay, so let's restart. So as we have already discussed in our previous video that what is generally a change is nothing but a transmission of any substance or any phase from one to another. Okay, it, like for example, if we talk about day and night, it is a type of change. Changing of day into night is a type of change. We see many different type of changes around us, and a change can be smaller, it can be bigger, it can be slower, it can be faster. So these are the types of changes that we have discussed in the previous video. But what is a change? Change is a transmission of any substances from one form to another. Okay, changing of anything from one form to another is known as change. Okay, transmission. Now let's talk about type of changes quickly. Okay, so in our previous video we have discussed about these all type of changes. The first one was slow and fast change. What are slow changes? That take time, right? For example, growing up is a type of change where it takes time for a person to grow up. Or if we say that we are planting a tree, so the tree will take time to grow up. Okay, if we are planting a seed, sorry, not a tree, if we are planting a seed, so the seed will take time to grow into a full-fledged plant, right? So it takes time. So those changes which takes time, which is slow, which takes times, that is known as slow changes. What about fast changes? Those changes that occur very fast, like lightning, for example, earthquake. These are examples of changes that occur very fast. Okay, then we have talked about desirable and undesirable changes. Desirable changes are what? Those changes that we wish for. For example, if we want to make curd, so that is a change that we want, that is a wish, desirable change. So whatever physical activity that we have to perform to change the curd, to change the milk into curd, we will do so. And undesirable changes are what? Those changes which are not desirable, or you can say those changes which are not wished by anyone. For example, if we talk about earthquake, it is not something that anybody or any person would desire for, like, right? So these are examples of undesirable change. Then we have also talked about periodic and non-periodic changes, right? So periodic changes are what? Those changes which occur after a particular period of time, or after repeating a change that repeat itself within a particular time. For example, let's take example of day and night. So day and night is a type of periodic change. Okay, and non-periodic change are what? Which those changes which does not have any particular form of time. Okay, it can occur in any period of time. Okay, so these were the types of changes that we have discussed. These were the brief details that we have discussed, but the chapter is basically about these four type of changes. Okay, reversible, irreversible, physical and chemical changes. So in this video we will be discussing about all these changes in detail, so that you can understand that how to identify a chemical change or physical change, or how to identify that a change can be reversed or not. Okay, so let's start, students. So let's first of all start with some example. Okay, if I say that I have given you a balloon and I have asked you to fill the balloon with air, so you can see that this action, this particular action can be reversed. As you can see in this picture also, that the balloon is getting filled after the air is inside it, and when the air is taken out, the balloon can regain its shape, right? It can regain its first position that it had particularly, right? So it is a type of reversible change. Reversible means a change that can be reversed, a change that can be reversed by the action that can be reversed, or a change that can be reversed. So as you can see in this picture here, that if we are filling the balloon, if we are if we are blowing the balloon, so what is happening, the air inside the balloon is the air inside the balloon is changing the shape of the balloon. And if we want to reverse this change, we can simply take out the air from the balloon, and the change will get reversed, right? So this is an example of reversible change. Now let's take another example. Let's say I have given you a dough, okay, and if through a dough I am asking you to make a ball out of it, okay, and then I asked you to make a round roti of it, from it, okay. So if you are making the roti and your roti is not gold, your chapati is not getting round, so what you can do is you can take the dough again and you can form the roll again, right? So this change is also a type of reversible change. You can reverse the action, right? But if I ask you, we will talk about that later. So this two here in this side, you can see these two are simple examples where you can see that a change can be reversed by simply reversing the action that we performed, right? For example, in the first phase, what we did, we simply blow the balloon, right? So to change the shape of the balloon, we simply put air, we put the we put the air inside the balloon. So this reaction can be reversed by simply letting the air from the balloon inside the balloon to go out, right? So the change of shape can take place again. So this action is reversible. We can change the action what we have performed. Similarly, making of dough, the rolling of dough can be a reversible change by making it again and again. If we don't like the dough, if we don't like the round shape of the roti, we can change the shape again by putting it on again as a by rolling it again as a dough, right? So these are examples of reversible change. So here by this what you can say is that what is reversible change? Changes that can be reversed are called reversible change. Those changes which we can reverse, okay, the action that we have performed in the change to put the change that have occurred, we can reverse it by simply undoing the action that we have performed, right? So that is known as a reversible change. So I hope it is clear to you by these examples that what is a reversible change, right? So students, these are some common examples where you can simply observe that these are they chemical change, are they reversible change or not. Now let's talk about changes like condensation, freezing and evaporation of a material, right? Let's see that these examples or these are what type of changes these are they reversible change? So we were talking about that. What about changes like condensation, freezing and evaporation? What type of changes these are? Okay, so let's say that I have taken out some ice cube from the freezer and I have kept them outside. So what will happen to the ice cube? The ice cube will absorb the heat from the surrounding and it will melt, right? We all know this is simple, right? So can this reaction get reversed? Yes, we can reverse it. How we can reverse it? By simply putting the liquid that has melted back to the freezer, and what will happen, it will freeze again and we will get the ice again, right? So if the ice that we have taken out from the freezer has melted, right, it has melted, and we can change this and we have got what we have got liquid. We can change this reaction by simply freezing it again, right? So this is a kind of reversible reaction where we can reverse the action that we have performed by simply unchanging, or you can say performing the reaction again. We can get the product that we have first, and after repeating the reaction, after reversing the reaction, we get the same product that we had first, right? Similarly, let's take example of evaporation. We know that if we heat the water, what will happen? It will start boiling and the steam will escape the container, right? As you can see in this picture that the water is boiling. So what is happening? The steam is getting out from the water. What if I put a lid on the container? So what will happen? The steam that is getting out from the container, it will again liquidify, right? It will again get condensed into small droplets. As you know, as you might have all seen that when we make different fruit, when we boil water, and if we have put a if we have put a lid on the container, after some time when we see the lid, you see some droplets on the lid. So that is due to the condensation of the liquid. So thus we can say that all the three changes that are being performed in these three options, that is freezing, condensation and evaporation, they can be reversed, right? So what we can say, thus the three physical state of water are reversible and can be changed from one stage to another by heating or cooling, right? All these are the forms, or you can say states of water, liquid, right? First one is the state where the water is solid, right? We it changes to liquid, and then the gas state. These all three states can be easily reversed by performing heating or cooling method on these all, right? So we can say simply that these all three states of water, that they are all three are type of reversible reaction. We can reverse the reaction by simply heating or cooling them. Okay, I hope you understood this part also. Students, let's move forward. So let's say I have given you a piece of paper and I have asked you to cut the paper into two pieces, and then I asked you to change the action that you have, or the action that you have performed, to back to the action that it was before. It means that give me the paper that I have given you without cutting it. So you can say, simply say that you cannot do this because the action that you have performed cannot be reversed, right? Similarly, making of food cannot be reversed. The food that we have made, after cooking it, the action of cooking cannot be reversed, simply reversed by, or the ingredient that we have put into the food cannot be regained by the process of anything. So you can simply say that these two actions are non-changeable actions, or you can say these changes are irreversible changes. So what is the definition, or what is simply a irreversible change? So a change that cannot be reversed is known as irreversible changes, right? The example that I have given you, in those example you can simply see that these actions cannot be reversed. So those actions that cannot be reversed are known as irreversible actions. Okay, similarly, let's see some more examples of irreversible changes. If we talk about blooming of flower, so this action cannot be reversed, right? If a plant is formed, if we have planted a tree, the change is not going to be reversed, right? Similarly, if we talk about rotting of a food, or rotting of a avocado, here in this picture you can see that rotting, the process of rotting means sar jana, okay? It cannot be reversed. So you see that these are examples of irreversible changes, where the change cannot be reversed by any means or anything. Okay, so these are some examples of irreversible change, and I hope that irreversible changes are clear to you all, right? What about if I say burning of a paper? That is also a kind of irreversible change. You cannot reverse the change by anything, right? The paper that have been burned cannot be reversed or cannot be achieved again. Okay, so these were examples of reversible and irreversible changes, and I hope that those two changes are clear to you all. Okay, students, now let's talk about the other type of changes. First, okay, so now we are going to talk about physical changes. Okay, let's take an example here of some physical changes, and then we will talk about the definition of physical change. So let's say melting of something. Okay, here are some examples of physical change: melting, shedding, boiling, chopping. So these are some examples of physical change. So what is the common thing that is happening in this physical change? Let's first of all read the definition, then we will see. Okay, so the definition of physical change is that the changes in which shape, size of the object may change, but the substance of which they are made of remain the same. Let's take first example. If we talk about the ice cream is made from the juice, the liquid, and the subsequent cream, that whatever that is used for it, right? So if the ice cream gets melt, so the form, the substance from which it is made, it will not change, right? The liquid from which the ice cream is made, it will still remain the liquid. It will not change into some form of guava juice. If let's take example, if the ice cream is of flavor orange, so the flavor of the ice cream or flavor of the liquid will not change even after melting. Similarly, in the second example, that is shedding of paper. Shedding means the tearing of paper. Okay, so the tearing of paper will change the form or the size of the paper. Yes, it will, but the paper will remain the paper. It is not going to change into wood or some other metal, right? Similarly, boiling of something, let's take example, boiling of water. If we are boiling the water, so the water, maybe the quantity of water will change the as it gets evaporated, but the water will still remain same after boiling also, right? Similarly, chopping of woods, cutting of wood means, if we cut the woods into pieces, the shape and size of the wood will change, but the wood will still remain the wood, right? It is not going to change into some other substance after chopping. So here in these four example, you can see and observe that the substance from which it is made, it is still same or similar even after the change, after going through the changing process. So these are known as physical changes, in which the shape and size, physical properties means the in which the physical properties of the substance changes. Okay, and in physical properties, the shape and size of the substance are included. Okay, so only the shape and size of the substance is changing, but there is no formation of any other substance, any new substance, and also there is no change in the substance from which it is made up of. Okay, now let's talk about the characteristics of physical change, right? So what are the physical change characteristics? During a physical change, only physical properties such as shape, size, color, and state changes. Okay, as we have seen in the first example where we talked about melting of ice or melting of ice cream, we see that the solid state, ice is a solid state, right? The state of that changes, it changes to liquid state, but the substance is similar, right? So physical properties, physical change includes physical properties. And what are the physical properties of a substance? It is the shape, size, color, and the state of the substances. Okay, when there is only change in the shape, size, color, and state of a substance, it means it is going through a physical change. Okay, now let's talk about the second characteristics. During a physical change, no new substance is formed, right? As we have seen in the four examples, there is no formation of any other substance. Only the substance from which they are made, they remained at the last. Even after changing, they remain the same, right? There is no formation of any new substance or any other substance. All the changes that has been done, it is either the shape, size, color, or the state of the substance of the thing that changes, right? So now let's talk about the third characteristics. A physical change can be either reversible and irreversible. Okay, yes, a physical change can be reversible or irreversible. Okay, it doesn't mean that all the physical changes are reversible changes. No, let's take example here. Okay, students, let's talk about a bulb. I have given you a bulb, and let's say it gets broken. Okay, so after that, if I try to put the bulb into the shape again, if I try to change the action that I've performed by reversing it, it cannot be reversed, right? The glasses, the bulb that I have broken, it cannot be changed, it cannot be reversed, right? Similarly, let's take another example. If I shed the paper, right? The size, the paper has been shed, the paper will not retain its position back, right? So these two example, from these two examples you can see that these changes cannot be reversed. Okay, and but these are also physical change where the only shape of the things are changing, right? Even after after the bulb is broken, the shape of the bulb or shape of the glasses are changing, but the substance from which it is made, it will remain same. Similarly, in the paper also, when we are tearing the paper, when we are shedding the paper, what is happening? The shape of the paper is changing, but the paper will remain the paper even after shedding. Okay, so here you can see that even though some changes are irreversible, it can be physical change. Okay, now let's talk about the fourth type of fourth characteristics, that is no very small amount of energy is either absorbed or evolved during a physical change. Okay, there is no energy transmission or energy taking process change takes place during the physical change. Okay students, so these are the these are the characteristics of physical change. If we observe these, any one of these, you can identify that either the change that is occurring is a physical change or a chemical change, right students? Now let's talk about another important point, that is expansion and expansion and contraction. Okay, so students, if I ask you, you might have seen, all of you, that the railway tracks are consist which are parallel to each other, they have small gaps, as you can see in this picture also. Here, these railway tracks have small gap between them. Why it is this? It is so because during summer, during hot weather, what happens, these metals, they get expanded. Okay, and due to this, what happened, it will extend itself. Okay, extend means it will get extended, and so the gap is given between the railway tracks. So the when the railway tracks or they expand, they doesn't get eloped. Okay, so expansion of solid, here this is example of expansion of solid. You can simply see this by in the railway tracks, where the railway tracks are given gaps between the railway tracks. As during summer, what happens, during hot weather, what happens, the railway tracks, they get expanded, so the gap is given so that when it get expanded, it doesn't, the parallelity between the railway tracks doesn't get overlapped. Okay, so and if there is no gaps between the railway tracks, it can cause accidents. Okay, so these is example of solid expansion. Now let's talk about expansion in liquid. Okay, let's read here. Water expansion of heating. Okay, water expand on heating. Let's try an activity here. Try this with the help, if you are going to try this activity, please try it with your elders. Okay, take a glass filled with water to its brim. Okay, take a glass and fill the water to its edge. Okay, fill the water completely in the glass, and then pour the water in a container and heat the water. Okay, do not boil the water, just heat the water. After heating, if you will put the water back into the glass, you will see that the water is overflowing. So this is a simple activity where you can see that the water also get expanded after boiling, after heating it. Okay, here you can see that liquid also expands while heating. Okay, okay student, we have talked about expansion of solids, right? Expansion of liquids. General example in which we can see expansion of solids is railway tracks. Okay, where this is used. And generally I have given you an example as an activity which you can also perform at your home to see the expansion of liquid. Now let's talk about another activity where you can see that how gas also show the expansion property. Okay, let's say that you have taken a balloon. Inflated balloon means you have filled the balloon, you have blown the balloon and put the balloon in the sunlight or outside where the sun is. Okay, so after some time you will see or you will observe that the size of the balloon will grow. Okay, it will expand in its size by taking the heat from the surrounding. This shows that gas also shows the property of expansion. So generally, what is expansion, students? Expansion is simply, you can define expansion as What is expansion? Expansion is simply the size of the substances change, right? So expansion can be, in simple words, expansion can be defined as a process in which an object becomes bigger in size. Okay, as I have shown you three examples where you can see that how solid, liquid and gas shows expansions. Now let's talk about another point, that is contraction. So if expansion means getting the size bigger, contraction means where the size get contracted, a process in which an object becomes smaller or shrinks. Okay, now let's talk about some examples where we can see that contraction of solid, liquid and gases. Okay students, let's see here. So let's talk about solid. Okay, if we hold a very hot glass of tumbler under a cold water, it will crack. This is because the outer surface of the glass becomes contracted. Okay, it comes direct into contact with cold water and it contracts more as compared to the inner surface. Okay, contracts means it will get shrinked. The outer surface of the glass, it gets shrinked compared to the inner surface, because the inner surface is not in contact with the cold water. So this is the reason why the glass get cracked. Okay, this shows that contraction of solid. Here you can see that how the glass got contracted as it comes direct into contact with the cold water. Now let's take example of liquid. We observe that water expand on heating. We have seen in the previous example where water get expanded when we heat the water. Now let's talk about what will happen to the water if we cool it down. Okay, so let's say that we have put the water and we have cooled the water and then pour it back into the glass. Will the water overflow? No, this is not going to happen. Okay, so this shows that this is because of contraction, right? As we in the previous part we see that we have heated the water, and when we put the water back into the container, the water gets overflowed, right? Similarly, if we take the water and we put the water in the freezer and we cold the water, we will see that the water will not overflow. This shows that the water is contracted. Now let's talk about gas. Gas also show the property of contraction and expansions. Let's talk about contraction of gases. If an inflated balloon is tied at the mouth of the bottle and the bottle is placed in an ice cold water, what will happen? As you can see here, the bottle is above the bottle, there is a balloon which is inflated and the bottle is put into the ice water. Okay, so after some time we will see that the balloon will shrink. Okay, as the air inside the balloon will contract as it gets cooled. Okay, it will get contracted. So here in these three examples you can see that how the contraction of gases, liquid and solid takes place. Now what is the importance of why we understood these 3 points, the contraction of the expansion and contraction? Basically we apply this property of contraction and expansion in our daily life also. Let's say that there is a jam bottle. Okay, it has a metal lid and you are not able to open the metal lid. Okay, so you can simply do what? You can simply heat the metal lid, and what will happen when we will heat the metal lid? It will get contracted, the metal will get contracted, and we can simply open the jar. Okay, so these are some, this I have given you a very simple example where you can see the expansion and contraction, a very simple application of expansion of solid, which we can use when a jar is not opening. Okay, now let's move forward from it. Okay, now we are going to talk about chemical changes. So what is a chemical change? Chemical change is a change in which composition and chemical properties of a substances are changed and a new substances form. Okay, the chemical properties and chemical composition of the substances will change, a new substance will form. Let's take an example, burning of paper. So you can see that when we burn the paper, first of all, it is an irreversible change. Yes, all chemical changes are irreversible. We cannot change we cannot reverse the reactions. We cannot reverse the changes. Okay, and you can see that when the paper get burned, the new substance that we get is the ashes, right? So here is the formation of new substances. So what here also in chemical changes, two things are very important. First is reactants and products. So what are reactants? The initial present substance. Like in this particular example, we are talking about initial substance, which is reactants. That is the paper, and for burning paper we will need a matchstick. Okay, so paper and the matchstick, they both are example of reactants. So what are reactants? The substances which are present that take part in a chemical reaction. Okay, they take part in the chemical change. Okay, these two will react with each other and the new substance is formed. That new substance which is formed is known as the product of product. Okay, so what is the product in this particular case? Ashes, right? Ashes means the rock. Okay, that is example of product. So in a chemical change, the two things that are important is reactant and product. Reactants are those substances which will present in the reaction, which will present in the change, and product is the final thing, the new substance that is formed. Okay students, I hope that is clear to you that what is chemical now. Okay students, now let's take very common examples of chemical change that we see around us. Okay, first one is burning, right? Burning, like we say, burning of paper, burning of candles. Okay, so here you can see that in a candle the two changes are taking place simultaneously together, right? What are the two changes? Physical and chemical changes. Okay, the first minor change is that the amount of the wax will melt. Here you can see the wax is also melting. Wax means the solid part is also melting. Okay, and due to the heat of the flame, right, it is melting due to the heat of the flame, but no new substance is formed, right? When the wax is melting, the wax will remain wax. It is an example where you can say, yeah, it is the shape of the candle is changing, the shape of the wax is changing, right? It is an example of physical change, right? And with the physical change, the change of burning, that is the major change that is happening is burning of wax. Okay, which will produce carbon dioxide and water. It is an example of chemical change. So here you can see that burning of candle is an example where two changes can be seen simultaneously or together. Okay, one is physical change. Physical change is what? The burning of wax. Okay, and what is the chemical change? Physical change is the burning, the melting of wax. Melting, where we see that the shape of the candle is changing, right? And what is the chemical change? The chemical change is when the wax is getting burned. Okay, so that is a form of chemical change. So in candle you can see both the changes simultaneously. Okay, now the second example is which is very common for a chemical change is rusting of iron. Rusting in Hindi we call it as zank lagna. Okay, so I hope that all of you are pretty familiar with the rusting of iron. You might have seen rusting of iron around you many times, right? So how rusting of iron takes place? It is basically a chemical change, right? In which what happens, the iron reacts with the oxygen that is present in the atmosphere, and it forms iron oxide, and iron oxide is the new substance that is formed. Okay, during this change, the iron oxide is the new substance that is formed, and it is generally called as a rust. We call it as rust. Okay, so rusting of iron is pretty much a common example of chemical change which occur around us. What are more examples that we can see or as a chemical change? That is cooking of food, right? Cooking of food is also a chemical change where a new substance is formed, right? Curdling of milk, that is also a chemical change. Digestion of food, which happens inside our body, it is also a part of chemical change. Germination of seed is also a chemical change. Okay, so these were some examples, common examples of chemical change, and I hope all of you now can identify what are chemical change. Now let's talk about the characteristics of chemical change, students. Okay, during a chemical change, one or more new substances are formed. Okay, when we perform chemical change, new substances form. which is pretty much we have seen in the examples also. Chemical change are permanent. Yes, it are permanent. It means it cannot be reversed. Okay, this chemical change cannot be reversed by simply physical method. We cannot change the the reaction, the chemical change that is that happened by reversing it. Okay, during a chemical change, relatively large amount of heat, light, or any other radiation may be given out or absorbed. As we simply talk about the chemical reaction, or the reaction where, sorry, the change of burning, right, the burning of candle or burning of paper, we simply see that the amount of light, the absorption of the in that particular example we can identify the heat, we can see the light, so that there we can conclude as simple that the chemical change is taking process. Right, now let's talk about the fourth characteristics, which is during a chemical change both the physical and chemical properties of a substance change. Right, but what in about physical change, only the physical properties change, right? But in chemical change what happens, students? The physical as well as the chemical properties of the substances changed. Like we preparing food, right? We are preparing food, so the properties, physical properties of the substance is also changing, right? Okay, students, so these are the characteristics of chemical change. So I hope you are able to understand what is chemical, what is physical change, what is irreversible and reversible change. Okay, so thank you, students. This was the whole video. If you have any doubt, as we all have a Zoom class in, sorry, the Google Meet on Tuesday, you can ask me any question that you have in your Google Meet. Okay, and I hope that all of you watch the video so that you have a doubt and you can ask me about those doubts in your Zoom sessions, in your Google Meet sessions. Okay, thank you so much, students.